Today we're going to talk about piecewise functions. So it's just what it sounds like. We're going to be using pieces of functions. So the definition of piecewise functions is they are functions defined by two or more sub-functions each with their own domain. Okay, so we're going to have a piecewise function that looks something like this. So I don't know why my brackets are so broken. I don't think yours, well, maybe yours are, but it should be one big bracket. I think I was having editing issues. So the function f of x is all three of these pieces here. And so this, I'm using this function if x is less than -3. I'm using this part when x is between -3 and 7, including -3, and I have this part if x is greater than or equal to 7. So you got to pay attention to the inequality part of that, like whether I'm including it or not. So let's look at f of -5. So I find -5 over here. I don't substitute it into all of them because I only use this if x is less than -3. Is 5 less than -3? Yes, it actually is. So I put it in this one. Do I put it in this one? No, because -5 is not between these two numbers and -5 is not greater than 7. So I only substitute it into the piece that makes sense. So it's going to be equal to 2 times the absolute value of -5 minus 5, which is equal to 2 times the absolute value of -10, which means that f of -5 equals 20. And this is my answer. And remember when I told you nitpicky little details that are important. I can't just put 20 and box that. What does 20 mean? They're asking you for f of -5, so your answer states f of -5 equals 20. So f of 2, I figure out where 2 lies. Doesn't lie here. 2 is in between these two, so I'm good. Doesn't lie here, so I'm only substituting it into this one. So it's going to give me I'm writing x, I'm sorry. -2 squared plus 4 times 2. And where that negative is important because it's outside. So I square the 2 and I get 4, so that's -4 plus 8. So f of 2, can't write. F of 2 equals 4. Right. Then I look at 7, f of 7. Okay, so there's a 7 here and a 7 here. I got to decide which one it falls in. This does not include 7, but this does, so I substitute it into this part. That's equal to the square root of 2 times 7 plus 6. Okay, so that gives me the square root of 14 plus 6. So that is the square root of 20. If you reach for a calculator, I will be very, very disappointed in you. I don't care what the decimal is. We're not using calculators, no. And I don't leave it like that. You need to know how to simplify square roots, whether you use the tree method or whatever. That's definitely old business. And f of 7 equals 2 times the square root of 5. I do realize that some calculators will reduce that for you too, but you still have to know how to do it without the calculator. Trust me. All right, let's look at number 2. And you can pause and try some of these on your own at any point. You're in control of all of that. So again, my bracket looks a little wonky here. I want g of -3. Well, -3, is that less than or equal to -4? No, it's not. -3 is between -4 and -2. So this is my function. So if I just had y equals 8, that's just a line. So that's a horizontal line. There is nothing for me to do. So when x is between these two numbers, the y value is 8 no matter what. Oops. So g of -3 is 8, and that's it. It's a constant function. All right, so then g of -8, well, -8 is less than or equal to -4, so that's equal to 1/2 times -8 cubed plus 7. Okay, so I know that this is going to end up being a negative number for sure. So again, let's talk about working smarter and not harder. This right here, and I'm not saying you need to always write it out this way, but I want to make sure that you know what I'm trying to say here. To multiply all that stuff out, that's 1/2 times -8 times -8 times -8. So again, no calculator here. And you can do this however you want. But grouping things together and doing whatever makes the most sense on that problem and makes your life easier on that problem is what you want to do. So if I multiply these two together, that gives me a -4. And if I multiply these two together, that gives me, it gives me a -4. Then it gives me a 64 here, right? And then remember, anytime you multiply by 4, you just double it and double it again. So 2 times 60 is 120, 2 times 4 is 8. So this is 128. So now basically I have -2 times 128. And if you break it up, -2 times 100, that's -200. 2 times 20, it's -40. 2 times 8, -16. So that gives me a -256. Then I add 7 to that. So that means that g of -8 is equal to -249. All right, 3.1. So I told you yesterday we do not like decimals unless we're forced to use them. They gave me a decimal, I'm going to use a decimal. No reason to make it into a fraction. Don't make decimals into fractions or fractions into decimals, or whole numbers into decimals. So g of 3.1. So 3.1 is going to be greater than or equal to -2. So this is going to be the absolute value of 3.1 minus 4. So that's going to give me the absolute value of -0.9. So g of 3.1 is equal to 0.9. Okay. So that's how we evaluate piecewise functions. Let's see how we graph them. Okay. All right. So before we figure out the domain, range, and the discontinuities, we're going to get it graphed. So I have 2 parent functions to deal with here. This first one is an absolute value, and the second one is linear, right? So I'm using the absolute value function if x is less than 0, right? So since it's less than, I'm going to have an open circle there. So I always start with the endpoints that I have, meaning that this is one time that I actually substitute in numbers and get an answer out, because I need when x equals 0, I need a point there. This is going to be open and this is going to be closed, but I need to know what the y value is. So if I substitute 0 in here, that gives me 3 minus 1, so it's 2. So at 0, 2, I have an open circle because it's part of this function, and it's open because it doesn't include it. And then I'm going to work with the rest of this function. I'm going to use my anchor points just like I did before, meaning that I have just 3 of those. So I'm going to start at -1, 1. If you need to write out your transformations, you can. I mean, it's not a bad idea at all. But -1, 1, that 3 means I go to the left 3, 1, 2, 3, and I go down 1. And I'm right here. So that took care of this point. Then I'm going to start at 0. Then I'm going to use the 0, 0. So I start here. I'm going to go to the left 1, 2, 3, and I go down 1. And I'm right here. Then I can do 1, 1. I go to the left 1, 2, 3, and down 1. Okay, and then I'm going to draw this in. But you got to be careful when you draw this in. Oh, and there is a line function on Cami. Thank you, David, for letting me know, because I still haven't had a chance to go look at it. The line tool, it's in shapes, which is under drawing, and the line tool is under the triangle. So if you want to use that to make your lines look a little bit better, you can do that. And I get to cheat with this. So I'm going to create this, and this goes through here like this. And I have arrows. Now, when I draw the other one, I do not get to continue all the way through. This is a big fat no-no. Okay, I'm going to bring it back. I have to stop at that open circle. Okay, it doesn't keep on going because it only works when my domain is less than 0. That's that part right there. So then I'm going to calculate my other endpoint. When I substitute in 0 here, 2 times 0, 0 minus 5, so I will be at 0, -5, 2, 3, 4, 5. And this is a closed circle because it's included, okay? And then this is a line, no reason to make it crazy. I know how to graph a line. I can use my slope. I already have the y-intercept, so it's in slope-intercept form, and that is my y-intercept. So my slope is 2. I'm going to go up 2 and over 1. There's my other point. And when I draw in the line, I start here and it continues on like this. So I'm actually graphing a ray, but it's because it's a piece of a line. That's the definition of, part of the definition of a ray anyway. And that's what my piecewise function looks like. Clearly has discontinuity. So now I have to answer these questions, my domain. All right, so I can see for my x values, I start way out here at negative infinity. I'm going to keep going. I don't get to use this x, but it does get used right here. So 0 is a valid x value, and then it keeps on going all the way to infinity. So it is all real numbers, or negative infinity to infinity. The range starts down here at negative 5. As I go up, all of the y values are accounted for all the way to infinity. So this is negative 5 to infinity. Don't include the infinities. I do have a point at negative 5. If this had been my open circle and this was my closed circle, then this would be an open interval. Okay. My discontinuities, right? There's no asymptote, so there's no infinite. And this isn't considered a whole or removable. This is jump discontinuity. So I have jump discontinuity at x equals 0. Okay, there's your first piecewise. All right, so let's look at number 4. All right, so I'm going to first calculate my endpoints. So x is less than or equal to negative 3. I substitute in negative 3 here. So I have negative 4 minus a negative 3. So negative 4 minus a negative 3. Don't mess up on signs here. That means that's going to give me a negative 1. So I'm going to go to the x value of negative 3 and negative 1, and it's closed because it's included. Then I'm going to, oh, I should have done my parent function. So this is a line, it's linear, and then this is a parabola, quadratic. So here's the thing about, so this, if I actually put it in y equals mx plus b, that's negative x minus 4. I don't want to find the y-intercept because it's only going to work over here. But I have a point. I can start from any point and count my slope. So a negative slope, I can go down and, I can go down and to the right, or I can go up and to the left. Well, I don't want any points up to the right of this point for my line. So since it's negative 1, I'm just going to go left 1 and up 1. There are my 2 points to get my line. And I have my arrow over here. So now the domain of this, it's all the x values less than or equal to negative 3. Now I'm going to substitute in negative 3 here. Be careful with your signs because we have negative 1/2, and then that negative 3 gets in here and it's squared. So that is positive 9 times negative 1/2. That is negative 9/2, which if you had to write the answer down, that's how you would write it. In order to graph it correctly, your brain probably needs to think about it as 4.5. That's fine. So I go to negative 3. And then I go to negative 4.5, 1, 2, 3, 4.5, and there's an open circle right there. Okay. So then I'm going to start graphing this part. I'm going to put in my anchor points. I have 5 of them for a parabola. So I'm going to start with this one, which is negative 2, 4. So I'm going to put my pencil on negative 2, 4, and then I'm going to do my transformations, which is a reflection in the x-axis. So I go down, hang on a second, negative 2, 1, 2, 3, 4. So I reflect down 1, 2, 3, 4. There's this point, and then I have a vertical compression of 1/2, so that becomes 2 right here. So then I go to negative 1, 1. So at negative 1, 1, I'm here. I reflect in the x-axis, shrink by 1/2, go to 0, 0, reflect, shrink, those don't change, so I'm right here. So here's what I know right now. I have this side of the parabola. So I have symmetry. This point has to be here, this point has to be here, and I don't necessarily need this point. I mean, I could put it over there, but it doesn't really matter. And this, ooh, I missed. This stops right there. This keeps on going. Okay. So my domain here, I go from negative infinity to Okay, I don't have a break in my domain here, and I keep going, so it's negative infinity to infinity. My range, go from negative infinity. This y value doesn't include here, but it is taken care of over here, so I'm good. So I keep going. There's no break in my range, so it's negative infinity to infinity. Do I have discontinuities? Yes. Once again, I have a jump at x equals negative 3. Okay. We are going to skip number 5. For 6 and 7, I would suggest maybe trying them and then, do a little bit on your own. Don't always just copy down everything I do. Take advantage of being able to pause, see if you can figure this stuff out, and then watch to verify yourself, or if you are not sure or whatever. Okay, so I'm going to start here. X is less than or equal to negative 4. So I substitute in a negative 4 here. 3 times negative 4 is negative 12, plus 8 is negative 4. If you need to jot that stuff down, that's fine, but it's a negative 4. So I'm going to go to negative 4, negative 4. And that is a closed circle because it's included. This is a line. So once again, I can just use my slope. I don't care that, yes, there's a y-intercept up here, but I know how slope works. From here, I could go up 3 and over 1, but I'm not supposed to have any x values to the right. So I really need to go down 3 and over 1. And then graph in my line. So that is all of my x values that are less than or equal to negative 4. Okay, so now if x is between negative 4 and 2, it's this. So when x is negative 4, y is 1. So I go to negative 1, negative 4, negative 1, but that's an open circle because it's not included. Okay, and it's going to remain negative 1. Okay, so the y value stays negative 1 until we get to 2, and that's a closed circle. And this is just a constant function. So then I have this. I'm going to substitute in 2. 2 minus 2 is 0 squared minus 5. So I go to 2 and then negative 5. 1, 2, 3, 4, 5. That is an open circle, right? And then, I didn't do my little parent functions here. Sorry, this is a lot. This is linear. Oh, I missed. Yeah, shoot. Fix that so I'm not confusing anybody. Should go there. This is constant at negative 1, and then this is a problem. Okay, so my parabola, I have 1, 2, 3, 4, 5 anchor points. So I'm going to start with negative 2, 4. So I'm going to go to negative 2, 1, 2, 3, 4. And then these transformations, I'm going to go to the right 2, 1, 2, and then down 5. 1, 2, 3, 4, 5. I do not get to make that point. I can't graph that point because it's not in my domain, right? So I'm going to go to negative 1, 1. So I'm at negative 1, 1. I'm going to go to the right 2, 1, 2. And then when I go down, I'm still not going to be in the domain I need, so that one doesn't work either. So then I'm going to go to 0, 0. Then I'm going to go to the right 2, and I'm going to go down 5. 1, 2, 3, 4, 5. Well, that is that point. But that's important for me to know because that's this point right here, which means I'm only going to get one side of my parabola. Otherwise, I might be confused as to why it doesn't really look like a parabola. So now I'm going to go to 1, 1. I'm going to go to the right 2, 1, 2, and down 1, 2, 3, 4, 5. And then I'm going to go, so that's that one. Then I'm going to go to 2, 4. And then I'm going to go to the right 2, and down 1, 2, 3, 4, 5. So when I draw this in, I know that this point is this point, so I'm only getting this half of the parabola, so it'll look like this. Okay? So let's look at our domain. Starting at negative infinity, this does get taken care of, so does this. So my domain is continuous, negative infinity to infinity. My range, I'm coming up here, right? I'm starting at negative infinity. I don't get to include this, but it gets taken care of right there, so I'm good. And then my range keeps going. All that's included in here. So once again, it's negative infinity to infinity. It's not always. So let me put that out there. Then discontinuities, I have jump at x equals 1, 2, 3, 4. X equals negative 4 and a positive 2. Okay. Now, I don't have time right now to do the last example, so the last example will be in a different video that's going to come a little bit later today, but hopefully before the end of the school day. Sorry, I'm doing the best I can to keep up with everything.